In an earlier video, we have shown you how to create this frequency distribution for rolling two dice at a time. Now, if we want to create this same situation for three die and see, because this looks like the uniform distribution, the one we showed before, is becoming more kind of like a normal. If we have more dies throw together, then it will look even better normal. Let's see that. So to create a sample space for three die, I need die number 3. So I will have the sample space for die number 2 and 1. When I throw die 1 and 2 together, I will have that. In addition to that, now I have another die. So for these are the sample spaces for sample space for throwing two dice. So these points like 1 1, I can get 1 1, I can get 3 2, things like that. Now for all of these two die situation, then if I have one more, throw one more die, that die has 6 faces. So 1 2 3 4 5 6. Now I can have a situation where I have all of these sample points for the two die, and then side 1 from my third die. Now I also have the second side, so I'm just going to copy and then I will change it later. Third side, fourth side, fifth side, and sixth side of the die. Here I still have side 1, so I'm going to change that using a formula. Just let me write it down first. So equals this plus 1. So what I want to do is every 6 rows is gonna change that to next side of the die. So as you can see, it ends at with 6. So I got that. Copy there, copy there, copy there, die 3, copy there, and copy here. Just for the visual, I'm going to add one extra column here so I can see it better, these sample points. So I added that. All right, so I have these sample points for 3 dice, 216 points total. Now what I'm going to do is I will copy that earlier mean calculation, and then I'll paste it here, and then I'll just change the number there. So this mean is from these values. Just change that, and this one is from here, and then this is from the third one, it's from the fourth one, and that one is from the fifth one, and that's from the sixth one. So I have that, and then I'll copy all the way up to the bottom to see. Let's have one extra column here just for the visual, so I can have some separations. Now I have, if you look at these, 1.333, 1.666, so this numbers is not like the number before. So what I have to do is I have to equals these. I'm not gonna type that, then I will lose some decimal points. I don't want to do that. So I want to just select this cell so that I don't lose any decimal points. See if this thing can copy. No, it's not doing exactly what I'm looking for. So from here it's not doing what I want. So this one is 3.666. I can choose this cell, and then this one is 4. I can choose this one. I can choose this one, and then I can choose 5, this, and then this one is 5.3, and then 5.666, and then 6. Now all I have to do is, everything is all formulas are done, so all I have to do is just copy that up to the bottom. So now I have, before for 2 dies, when I throw 2 dies I had 11 categories. Now I have 16 categories. So this should look a little bit better than before. So let's go ahead and insert a XY scatter like that. You can see it's getting better and better. Now let's go ahead and create a, let me title that. So always y-axis is the probability or frequency axis, and then x-axis is the mean of the x's. So mean of x or xx, like that. So this is looking better. So you have one dimensional, one die was a linear distribution, and then when we throw 2 die and take the average, it start to become normal. Look at 3 replication, throwing 3 dies is looking better. Now let's go ahead and do it for 4 die, throwing 4 die. So I'm going to name this page as 4 die. So if I throw 4 die, then what will happen? So what I will do, I'll basically copy everything from the 3 die situation and then keep adding stuff. I'll delete that away. So let's go ahead and insert one more column after each of these sample point sets. Insert, and then insert one more here. Now my 4th die, similarly I'm creating that sample space like I did for my 3 dies. So you can go back to the video a little bit to see how I created the sample space for 3 die. It's the exact same principle as that. So what I'm gonna do is basically create, so these sample points are from 3 dies. So if I now add one more die that can have side 1, side 2, or side 3. So for all of these sample point, I'll have to have 1, and then for all of these I'll have to have 2, 3, and so on for that die number 4. So what I'm gonna do is Sweet Excel. I can just copy and paste and show really nice things. What I'm gonna do is now copy all of this data, Control C, and then just keep going, Control V. That's for the second side of the die. So that's 2nd, 3rd, 4th, as 5th, and 6th. So that's it. Now what I'm going to do is, this cell I will change as equal to this plus 1. So what this formula will do, every 36 cell it will add 1. So what's going to happen is you will see somewhere around this 75. So another 36 started 3, and so on. It should go all the way to 6. So that looks okay. Now what I'm gonna do, I need to copy that for all my other 4th die. Perfect. Now what I'm gonna do is just change these averages. That will basically fix my stuff right away. So that is gonna be, I'm gonna expand that. This average I will expand, do that. What I can do, I just add one more, so it's 3. I can just type 4. Oops. Basically It's gonna be S3. Sorry about that. S3. I can type that, so that way it's gonna be easier. So this one I can just change that to X. That should fix. This one I can type AC instead of AB. That should fix my averages. So now I calculated all the averages of my possible sample point. So if I draw four of these die, and I can have a situation where I can get all of them sixes, and the average of that is 6, as you can see. So I use this formula in Excel to calculate that. Let's go back and then finish rest of the calculation. Now it is increasing 1.25, 1.5, something like that. So 1.25, 1.5, that looks very close to, some of the stuffs have already been fixed, but it's not, just because it's not okay. So it's not all of them fixed because it's choosing the cells. So what I can do in this case is basically equal to this plus point, this plus 0.25. That way it will be adding 0.25 to, I don't need anything after 6. I don't have any value after 6. So alright, so now if I just copy that, so everything fixed, now I can plot this and see it should look much better normal now. Look at this. If you compare the earlier graphs, this is getting more and more normal. So frequency or probability, and then this way is the mean of x's. That's what I have. So now I throw 4 die and it's looking much better. I can do, so if you go back 3 die, that was the 3 die situation. There is the 4 die. It's looking much better than 3 die. If you go to 2 die, it's much better. Let's go ahead and do one more 5 die so we can see what happens. 5 die situation. I'm gonna copy everything from the 4 die page and then use that as a base template. For that will save some of my time. So I'm gonna just delete that. I don't need that. Now I'm going to add one more row just for the visual, and then I will add the 5th die with the mix. So then I will have a 5 replication for this die experiment. So I got D5, copy that, paste it here, paste it here, here. So now I have 5 die. Same thing for these are the sample space, sample point from 4 die. Now with this sample space, for each of these sample space, each of these point, sample point, I can have one from the die 5, I can have side 2, side 3 from die 5, and so on. So what I'm gonna have to do is have this number for all of these. So it's gonna copy nicely. That's good. Not gonna check that. So let's go there, copy, paste. So this is only giving me just for die number 5, side 1. I need to have side 2, 3, 4 all the way up to 6. So side 2, side 3, side 4, and then side 5, and then final side 6. I go back to there, and then I'm gonna change this number in a formula where every 216 points it will add 1. So this equals, I'm gonna select the first cell, this one, plus 1. So what this will do is every 216 row it will add 1. So let's go ahead and check that. As you can see, it should go all the way up to 6 like that. So now what I'm gonna do is I'll copy this for each of these die 5 cell column, and then that's fixed. So I got sample space for 5 dice. If I do throw 5 die, this is the sample space for the 5 die. Now I'm going to have the mean calculated. So this one I'm going to change by E, and this one will be JK, and then this will be PQ, Q, and the next one will be VW, and then next one will be SC, then this one will be HJ, HI. So all right, so it's almost done. Now it's not copied all the way down, so we gotta do manually drag that to all the way up to that 1200 some data points rows. So you got all these possible situations. Now as you can see, it's increasing 0.2, so this one is a little bit easier. So what I can do is basically 1.2 and then just simply copy that all the way up to 6. That's not good. I'm gonna type another formula, this plus 0.2, and this should work. Alright, so I don't have anything after 6, so I'm going to delete that. Now let's expand that to 6 just to double check how many points. Now I have 26 points, and then just span that all the way. Oh, I don't want that. So just drag that 2 up to that point. Now if I plot that for this, it will look much better normal distribution than what we have for other situations. So let's have the title, always title. Without title, we don't have any meaning. So probability or frequency, similar thing. And then in this direction, I have the means of the mean of x's. So as you can see, we started from this linear distribution. So originally it was the linear distribution, and then we have collected multiple data for this, and then it start to, for 2 samples already start to getting normal, and then 3 replication, 4 die, 5 die looking much normal. So this is the central limit theorem. This is the basic to many statistical analysis. We'll see that later.